Hello everyone and welcome to Edupedia World. Today's lecture is covered under the following heads. We will start with applications of neutralization reaction. The important applications of neutralization reactions are: it reduces the acidity of soil. The acidity of soil is reduced by adding slaked lime, that is calcium hydroxide, to the soil. An acidic soil is harmful for the growth of plants. The second important application of neutralization reaction is in antacid tablets. Excessive hydrochloric acid produced in the stomach of a patient suffering from acidity is neutralized by giving antacid tablets containing magnesium hydroxide to the patient, and the reaction which occurs is twice HCl. This is the excessive hydrochloric acid produced in the stomach. It will react with magnesium hydroxide, which is a basic ingredient of antacid tablets. It will form MgCl2 and water. So this is the reaction which occur. The third application is drinking of milk which is alkaline in nature neutralizes excessive hydrochloric acid produced in the stomach. And the stings of ants and bees contain formic acid, which is neutralized by rubbing it with a solution of soap which contains free sodium hydroxide, slaked lime, or a very dilute solution of ammonium hydroxide. The another application is the stings of yellow wasps contain an alkali which is neutralized by rubbing with vinegar, or we can say that vinegar is nothing but a dilute solution of acetic acid. Another application is in the harmful level of carbon dioxide in submarines and spacecraft is neutralized by using a base lithium hydroxide. Now, use of the terms concentrated and strong in acids and bases. We use the term concentrated and strong while expressing the concentration of an acid or a base. The strength of an acid or a base is its ability to ionize in aqueous solution and is measured by the ability of its aqueous solution to conduct electricity. Concentration. What is concentration? Concentration is a measure of quantity of a solute in a given mass or volume of a solution. A concentrated acid has more moles of acid per liter of its solution in comparison to a dilute acid which has lesser moles of acid per liter of its solution. We can also say that a dilute acid has more water and less acid, while a concentrated acid has more acid and little or no water. Since a weak acid ionizes in water only to a small extent, a weak acid remains a weak acid even when it is more concentrated. Since a strong acid dissociates in water to a greater extent, a strong acid remains a strong acid even when it is less concentrated, or we can say dilute. Dilute sulfuric acid is stronger acid than concentrated acid. The reason behind is dilute sulfuric acid is stronger acid than concentrated acetic acid. Chemical formula of acetic acid is CH3COOH. The reason is dilute sulfuric acid ionizes to a greater extent. In comparison to concentrated acetic acid and dilute sulfuric acid also has greater conductivity. This is the reason that why dilute sulfuric acid is stronger acid than concentrated acetic acid. Next we will discuss uses of acids and bases. First we will discuss uses of acids. Hydrochloric acid. Hydrochloric acid is used as a toilet cleaner, pickling of metals, stain remover. It is also used in swimming pools, digestion of food and killing of bacteria in the stomach. The next acid is boric acid. It is used in eye wash, talcum powder and dusting powder. Now acetic acid. Acetic acid is used in cooking in the form of vinegar. It is used in food preservation and manufacture of rubber. Nitric acid is used in explosives and jewelry. Now we will discuss uses of bases. Sodium hydroxide. Sodium hydroxide is used in manufacture of soap, drain cleaner and oven cleaner. Now calcium hydroxide. Calcium hydroxide is used in manufacture of bleaching powder, in softening of water, whitewashing. Next, aluminium hydroxide. Aluminium hydroxide is used as a foaming agent in the extinguishers. And ammonium hydroxide. It is used for grease stain remover and household cleaning. Our next topic is basicity of acids. The basicity of an acid is the number of hydrogen ions which can be produced by the ionization of one molecule of the acid in aqueous solution. For example, the basicity of hydrochloric acid. Basicity of hydrochloric acid is 1. Why it is 1? Since one molecule of HCl produces one H positive ion in solution. The basicity of sulfuric acid. What is the basicity of sulfuric acid? It is 2. Why it is 2? Since one molecule of H2SO4, one molecule of H2SO4 produces 2 H positive ions in solution. This is the reason that H2SO4 basicity is 2. The basicity of phosphoric acid H3PO4, its basicity is 3. Why it is 3? Since one molecule of H3PO4 produces 3 H positive ions in solution. So basicity of phosphoric acid is 3. Basicity of an acid does not depend upon the number of hydrogen atoms present in one molecule of the acid. It depends on the number of ionizable hydrogen atoms produced by the acid in solution. For example, ethanoic acid ionizes in solution to give only one H positive ion in solution, although it has 4 hydrogen atoms in its molecule. So ethanoic acid is monobasic acid. The ionization of ethanoic acid is given in this chemical equation: CH3 COOH. It will ionize C and form CH3 COO minus and H positive. This is acetate ion, and this is ethanoic acid. So the basicity of an acid does not depend upon the number of hydrogen atoms present in one molecule of the acid, and it depends only upon the number of ionizable hydrogen atoms produced by the acid in solution. Now we will discuss some solved questions related to this topic. Our first question says, question number 1, it says, what will be the concentration of H positive ions in solution when pH is 0? When pH is 0, the concentration of H positive ions is 10 to the power 0 mole per liter. That is, concentration of H positive ion is 1 mole per liter. Now next question, question number 2, it says pH of gastric juice lies between 1 and 0. So the sub question says, which substance is responsible for specific pH of gastric juice? Which substance? The answer is hydrochloric acid is responsible for the specific pH of gastric juice. The second question, the sub question says, is it acidic or basic? Answer is gastric juice is acidic since its pH lies between 1 and 2. The third question says, how is this pH range helpful in digestive system? The acidic pH of gastric juice helps in the digestion of food. It helps in the digestion of food. Without harming stomach, hydrochloric acid breaks down the complex foodstuffs into simple molecules. Our next question. 3 acidic solution A, B, C, and they have pH 0, 3 and 5. Question number 1 says, which solution has highest number of H positive ions? Highest number of H positive ions. The answer is A. The solution A has highest number of H positive ion since the concentration of H positive ions in this solution is 1 mole per liter. The second question says, which solution has least number of H positive ions? The answer is C. The solution C has least number of H positive ions since the concentration of H positive ions in this solution is 10 to the power minus 5 mole per liter. Now we will discuss another question. You have two solutions A and B. The pH of solution A is 6 and pH of solution B is 8. First question says, which solution has more hydrogen ion concentration? More hydrogen ion concentration. The answer is the solution A has more hydrogen ion concentration. The second question says, which solution is acidic and which one is basic? The solution A is acidic. A is acidic. Why A is acidic? Because its pH is less than 7. So it is acidic. And the solution B is basic. B is basic. It is basic because pH is greater than 7. Now we will discuss another question. This question says 5 solution A, B, C, D and E when tested with universal indicator showed pH A, B, C, D and E. When they tested with universal indicator show pH as 4, 1, 11, 7 and 9. So the question says which solution is neutral? Solution D is neutral because pH is equal to 7. So this is the reason why solution D is neutral. Which solution is strongly alkaline? Solution C is strongly alkaline. Why it is strongly alkaline? Because pH is greater than 7. Strongly acidic. Solution B is strongly acidic. Weakly acidic. Solution A is weakly acidic. And weakly alkaline. Solution E is weakly alkaline. Now, next question. Question says, sweet tooth may lead to tooth decay. Explain why. What is the role of toothpaste in preventing cavities? The solution is, people having sweet tooth have a liking for sweet tasting foods. Sugar, chemical formula of sugar is C12H22O11. This is the chemical formula for sugar. Sugar adhering to our teeth after eating sweet tasting foods and not brushing the teeth after eating sweet tasting foods undergoes bacterial decomposition, and as a result hydrochloric acid is produced as one of the products. Hydrochloric acid reacts with calcium phosphate present in our teeth to form soluble calcium chloride, and as a result there occurs tooth decay, and in the long run we get cavities in the teeth. Toothpaste are slightly alkaline and neutralize hydrochloric acid, and the chemical reaction which occurs is Ca3PO4 whole twice when it reacts with 6HCl, CaCl2 calcium chloride, thrice CaCl2 and twice H3PO4 is formed. Toothpaste also contain colorless coating materials, and our teeth get coated with these coating materials, and as a result of this teeth are not attacked so easily by hydrochloric acid. Moreover, brushing with toothpaste removes the food particles containing carbohydrates, and as a result the formation of hydrochloric acid is drastically reduced. This prevents the formation of cavities. In the fluoride toothpaste, sodium fluoride is added in order to prevent the formation of cavities. Sodium fluoride reacts with calcium phosphate present in our teeth to form soluble calcium fluoride. The chemical reaction is Ca3PO4 whole twice when it reacts with sodium fluoride. It will form thrice CaF2 and twice Na3PO4, and as a result hydrochloric acid cannot now attack calcium phosphate. Thus, brushing of teeth with fluoride toothpaste prevents the formation of cavities. Our next question: under which conditions of soil do you think a farmer would spread or treat the soil of his fields with quicklime or slakelime or chalk? The solution is plants usually do not grow in alkaline soil as well as in highly acidic soil. The soils with the pH values in the alkaline region and highly acidic region are not fertile for plants. Hence, a farmer should treat the soil of his fields with quicklime, slakelime, chalk if the pH value of soil of his fields is in highly acidic region, so that the pH value of soil changes to less acidic region. Thanks for watching Edupedia World videos.